Hello, mathletes. This is Miss Rhodes here. Just wanting to talk to you about simplifying rational expressions. The first thing is we need to know what a rational expression is. So hopefully you've taken some time to look at some examples and non-examples before I go over the definition with you, which the definition is going to be a ratio of polynomials which has a variable in the denominator. And as you'll recall, a ratio can be a fraction, which a majority of these examples are. And so we'll have variables like x in these examples. The non-examples you'll see, while some of them are already whole numbers like the 7 and 18, you know that once you simplify the expression 4 plus 3 quantity squared, you will get a number, not a variable, which makes this a non-example. Moving on, steps to simplify, what you want to make sure of is you are going to factor everything. That is step 1. Step 2, you are going to cancel factors, not terms. And we'll look at some examples to see what you should know about this. But remember, anytime you cancel a term, so in this example, they're canceling out x squared, those are not factors, those are terms. So a cute little kitty dies. So this poor little kitty just died if you did that. So don't kill kitties. They're awesome. Finally, step 3, you're going to check to make sure your answer is fully reduced. So now let's look at some examples. So our first step is 60x cubed over 12x squared. The first one, I want to write out the factors for you a little bit more than what I may do in the following examples, just because I want you to see that 60 is really 12 times 5. Then I have times x times x times x. And then in my denominator, 12x squared is really 12 times x times x. So I'm looking at factors, so that's the numbers that are being multiplied. So the ones that I'm going to cancel, I can cancel out the 12s because I have 12s on both the top and bottom. Then I have one set of x's that I can cancel, and then another set of x's that I can cancel. Therefore, when I clean this up, in my numerator, I have 5 and x, so we can just put 5x. And in my denominator, everything is canceled out, so it can be 5x over 1. And then we need to reduce that to just 5x. When I'm looking at B, example B, I have 3x over 3x minus 1. So you have one term in the top, which is 3x, and you have one term in the bottom, which is 3x minus 1. Or, sorry, two terms, but one factor. So, since 3x and the negative 1 are not being multiplied, we cannot factor these anymore. Therefore, your final answer is 3x over 3x minus 1. Example C, we have x plus 2 times x minus 3 over 2x minus 3 times x plus 2. So again, we're canceling factors, not terms. So I have a factor here and a factor here. Both of them are x plus 2, so I can cancel these bad boys out, which leaves me with my numerator of x minus 3 and my denominator of 2x minus 3. And that is your final answer for example C. Example D is reduced, so I'm just going to copy that. I have 3 times x times y. And then on the bottom, I can factor this out. 3 times 4 times x times y times y. Then I'm going to grab my green pen so I can cancel some factors out. My 3's can cancel. I can cancel one set of x's and one set of y's. Now, since everything is canceled on top, that doesn't mean that's 0. Remember, that is 1. Since we've reduced, we're basically dividing. So what is left there is a factor of 1 in the numerator. And then what's left on the bottom is 4 times y, or just 4y. Example E, I have 5 times x minus 3 over 15 times x plus 3. So as you can see, these factors are not the same, so I cannot cancel these out. These are going to stay the same. However, I can reduce 5 over 15 to 1 over 3. So if I do that, then I can have, it's 1 times x minus 3, so I'm just going to put x minus 3 over, and remember we have to completely finalize our answer, so we're going to distribute that 3 to the x and the 3, so 3 times x is 3x, and then 3 times 3 is 9. So our final answer is x minus 3 over 3x plus 9. Next, we have 8x and times x minus 3 times x minus 1. Then it's all over 2x times x minus 2 times x minus 3. So as you can see, we can cancel these factors since they're being multiplied. I can cancel out my x's. I can also cancel out the factor of x minus 3. And I can also cancel out my 8 and my 2 to reduce to 4 over 1. Then remember, we do have to multiply everything out, so I'll rewrite it so it's easier for you to see the distribution of this one. So 4 times x is 4x, 4 times 1 is 1. All over, and since I'm just multiplying by 1, I can just write x minus 2. And that is your final example for just canceling like factors. You are going to do mixed practice now, and then when you get done with mixed practice, then you can move on and continue examples of factoring and then canceling like factors. Welcome back. This is the final example section of canceling like factors. So in this section, we have to factor before we cancel our like factors. So as you've done in Unit 7A previously, you learned how to factor. So whether you wanted to use the box method or the X method, I am going to just tell you what these factors are. So x squared plus 7x plus 10. If I factor that, I have 2 factors of x plus 5 times x plus 2. And that's going to be all over. I see that I have a x squared minus 4. Both of those are perfect squares. So it's going to be x minus 2 times x plus 2. Since we have no x term in there, I know that and they are both perfect squares. I know that both the first terms have to be the same and the last terms have to be the same, just one is positive and one is negative. So now it's time to cancel. So of course we have the x plus 2's in the numerator and denominator, so we can cross those out, which leaves us with our final answer of x plus 5 over x minus 2. Next is our example B. So I am going to factor out, since I have my greatest common factors of both of these, I can take both a 2 out and an x out of these. So I'm going to take 2x and then put in parentheses. If I factor 2x out, I know that I still have 1x being multiplied. And then if I take 2x out here, 6x divided by 2x just gives me a positive 3. So again, just to go over this in case you see this and are like, OMG, Miss Rhodes, you did this too fast. I basically factored out the greatest common factor that goes into both of these terms. So if I were to distribute 2x times x gives me 2x squared, and 2x times a positive 3 gives me a positive 6x. So that's how I factored that. Since I didn't have to FOIL, there were only two terms. The second one, the second expression in the bottom, or polynomial, can factor with x plus 3 times 2x plus 1. And you can do that again by either using the box method or the X method to factor those. Looking at our common terms, I see that I have an x plus 3 in both the numerator and denominator. So I'm going to cross these bad boys out, which leaves me with a 2x in the numerator and a 2x plus 1 in the denominator. Now I know some of you guys are going to want to try to kill kittens and are going to see, hey, Miss Rhodes, there's a 2x in the numerator and the 2x in the denominator. But remember, both terms need to be being multiplied, not being added. So if this 2x, if this denominator had a 2x times 1, then we could cancel the 2x in both the denominator and the numerator. But since we don't, the 2x plus 1 is a term in and of itself, and the 2x is a different term. Next we have example C. I can only factor out my greatest common factor of my two terms in the numerator is 2. So I'm going to take a 2 out. So 4x divided by 2 is 2x. And then negative 10 divided by 2 is a negative 5. Again, we have some perfect squares on the bottom. So I can take the square root of 4x squared, which gives me 2x for both of my first terms. And then I have a perfect square, so that is 5 times 5 gives me 25. Notice that your 25 is negative. So 1 has to be positive and 1 has to be negative. Then looking at terms to cancel, I have 2x minus 5 in both the numerator and denominator. I cross those bad boys out, and that leaves me with 2 over 2x plus 5. Finally, our example D has a lot of things going on with it, so I'm going to go one step at a time when factoring. First off, I see that I can factor out a 3 in my top two terms, so I'm going to do that to make it 3 times x squared minus 9. And I know some of you already see, Miss Rhodes, x squared and 9 are perfect squares, so we can factor this. Yes. And if you want to do that now, you can go for it. I'm going to wait one more step to do that, just so some of the people that take some more processing time, myself included, can have some extra workspace to make sure that they do not make a mistake. Next, I'm going to factor my denominator, which is x plus 3 times x plus 3. Your second step, you need to factor more. So again, we see that x squared minus 9, both terms are perfect squares. So x times x gives you x squared. And then my term 9 is a perfect square, so I can make 3 and 3. And since it's the difference of squares, one has to be positive and one has to be negative. And then I can just drop down my denominator, x plus 3 times x plus 3. And now we can cancel out factors. So I have x plus 3 on both top and bottom. So I'm going to cross those bad boys out. And our final answer, remember, we have to distribute. So that leaves me with 3 times x, which gives me 3x. Then I have 3 times a negative 3, which is a negative 9, all over x plus 3. So your last part of this is your exit ticket. So you are going to simplify the rational expression below. You do not need sentences this time. You're welcome. I am very happy to allow you to not write this time. Don't tell Miss Calloway. Just circle your answer, and then you can check with Miss Calloway to make sure it is correct.